Okay, so we're moving on to the next one. Just trying to see if I have an option for making this a little bit cleaner than what I'm already doing. Let's maybe go to a thicker line, see if that doesn't help us out. All right, so again, we're going to start off with our formula. We've got 1/2, that's much better. Base 1 plus base 2 times the height. And really, I'm going to turn it sideways, and I'm going to show you, so 15 is one of my bases, and then I have to go find that second base, which would be 15 plus 5. We've got 1/2, one of our bases with 15, the other one would be 20, and then I don't know that height. That height is right there, so I'm going to have to go use Pythagorean's theorem to find it. So I'm going to come down here. X squared plus 5 squared is equal to 13 squared. And when you take 13 squared minus 5 squared and take the square root, you end up with a height of 12. Now we can finally plug it into our calculator and we come up with an area of 210. Now if you wanted, you could have split it up into two separate shapes, totally up to you. I was just going with the fact they told me that I had a trapezoid and that's what I was looking for. Let's type in that answer, see if we got it right. Next one, they want to know what is the area of the regular polygon. So the formula we had been using, and again you've got two options. I'm going to go with the first option, which is probably the easier option. If you recognize you have a square, and a square is also a rhombus. If this piece here is 2, that means that whole diagonal is 4. So one way we could do this is using 1/2 d1 times d2. One of our diagonals is 4, and actually the other diagonal is 4 as well, because the diagonals in a square are congruent. Now, if you don't want to do that, let me see if I can erase. Oh, I didn't want to erase the whole thing. Sorry about that. Your other option is to keep it as it is. So let's go ahead and draw that out. And what we would do is notice there's 4 triangles. So that means we have 4 1/2 base times height. Right now, all I know is this is 2, but we end up with the 45, 45, 90 triangle. So to get from the leg to the hypotenuse, I would multiply it by radical 2. So I could do 2 radical 2 times 2 radical 2, or if I go into what we'd done before, my base is 2 radical 2, I'd have to go and find this length right there. So let's fill in what we know. We've got a base of 2 radical 2. This piece right here would be simply a radical 2. Because if the whole thing is 2 radical 2, each one of those smaller pieces are radical 2, and those legs would be the same. Obviously the other method's going to be a little bit easier, but trying to cater to both, we ended up again with an area of 8. Right, it says find the area of the regular polygon with a given apothem and a side length of s. So it tells me I have a pentagon. That means I've got 5 triangles. So I've got 5 1/2 base times height. It tells me that the side length, which corresponds with one of our bases, is 14.7. Tells me the apothem, which is the height of one of those triangles, is 10.1. Now we're simply multiplying it all together. And we end up with 3 decimal places, so 371.175. 371.175. Next, area of the octagon. Again, we're going to start off with the number of triangles, which is 8 times 1/2 times base times height. In this particular case, I at least know one of the bases, and that is 44. What I don't have is the height. Let me go ahead and draw one of those triangles a little bit bigger. This is 44. Oh, and actually I do have the height of one of those. It's 53. So similar to that last one, I have all of the information that I need. We end up with a 9,328 for this particular problem. 9,328. Okay, we've got a hexagon, so that means we've got 6 triangles. So again, we're writing out 6, 1/2 base times height. We've got 6, 1/2. I can quickly see my base is 24. What I'm missing is the height. So let's come over here, pull out just one of those triangles. Again, this is 24. I drop in that height. If I go do my little 360 divided by the number of sides divided by 2, I end up with a 30-degree angle. So this angle up in here is 30 degrees. I know that this piece is 12, which is the short leg, and to get to the long leg, which is my height, I multiply by radical 3. And this one says we can take it to the nearest tenth, so I'm typing in 6 times 1/2 times 24 times 12 times radical 3. And it says round to the nearest tenth. I'm getting 1,496.5. All right, 1,496.5. All right, in this particular case, again, it's a hexagon. So we've got our same formula that we used on that last one. And in this particular case, I don't know the base or the height. But again, the nice piece is I've got the hypotenuse is 4. So to get from the hypotenuse back to the short leg, I multiply by 2. And then to get to the long leg, which is the hypotenuse, I multiply by radical 3. So here we go. 6 times 1/2. Our base would be this whole length, which would be a 4. And then our height is 2 radical 3. Now, if you notice in these directions, it says leave it in radical form. So I'm going to cast off that radical, multiplying 6 times 1/2 times 4 times 2, and we get a 24. Let me just confirm, radical 3. All right, last two. What is the area? If you look at your formula for area of a triangle, we've got 2 formulas. We discussed those earlier. 1/2 base times height. I do have the base, I don't have the height, which I could go drop it in, or if you look at that second formula that we mentioned, we could go and use 1/2 BC times the sine of A. Again, B and C are any 2 sides, so I've got a side of 3, a side of 6, and the angle in between them is 32 degrees. So typing all of that in. And I end up with an answer of 4 point, it says round to the nearest square inch. So that means I can round, I get 4.7, but to the nearest square inch, that would be a 5, and a messy 5. All right, last problem. I have a side length of 14 in an octagon, and I have to go and find its area. Again, we've got 8 triangles. I'm going to go and pull out one of those triangles. We know this is 14, so that means I have the base. And I did notice on your quizzes, several of you forgot to multiply by the number of sides. So be careful of that on these particular problems when you're checkpointing. Okay, I'm going to go drop in this height. I've got to go figure out what angle measure that is. So again, we're doing 360 divided by 8 divided by 2. Sorry about the mess. And I get 220. So this angle up in here is 22.5. We've got then opposite over adjacent, which means I'm using tangent. So the tangent of 22.5 equals 7 over h. I'm going to go and divide. H is equal to 7 divided by tangent of 22.5. I'm going to have to go buy a stylus. 7 divided by tangent of 22.5. I end up with a height of 16.899. All right, I'm going to go ahead and type all of that in. It says round to the nearest whole number. I'm coming up with 473. If you need some more detail, certainly you can post it on the discussion board and I can videotape it out in a better form that I've got. Let's go ahead and type that answer in, and we have got 473. And I've just erased all of my work. Let me try again. We had 8 sides times 0.5. One of the sides was 14, and my height was 16.8999. I got something different this time. Let's try it. I got 946. Thinking maybe I took an extra half in there somewhere. There we go. Any other questions you need, post them on the discussion board. Checkpoint A is due tonight by midnight.